Alright, so we are starting the new unit today. Again, please make sure that you do the homework, whatever we don't finish, and you have it by next class. So here's the thing. If you're inundated with homework from other classes, and you would choose, let's say that, man, I had so much homework I couldn't turn it in the Thursday that it was due. As long as I get it that week before you go on the weekend, I'm okay with that. But I just need you doing that practice. You see what I'm saying? Just keep that in mind. I don't want to kill you with homework, but at the same time, that hour of practice that we need, I definitely want to make sure that we are doing those. All right, so our next unit that we're going to be covering is Passport to Advanced Math. All right, we're going to look at number 1 through 4, quadratic functions, solving equations, quadratic formula, imaginary and complex numbers, and last but not least, polynomial functions. Again, the things that I'm going to be touching light on are the things that I think if you strengthen your head, way above the competition in that respect, just because of the way that things are tested. All right, so there are 3 forms. So we talked about this during the summer camp. The first one is the vertex of a quadratic formula. And if we have the standard form, it's this right here that you see highlighted right here. If it's in standard form, the negative b over 2a will give you your x value. And when you plug that into where x goes, you will be able to get as an output y value whatever this is. Okay? That is in standard form. Remember, negative b over 2a. Now, this is the x value that tells us where the vertex is located. This is the y value that tells us what is the value. Okay? Make sure that we take heed to that because of the example problems that we're going to be touching on here in just a bit. So the second form is vertex form. And this one is very, very user-friendly because of what we did with transformations back in Algebra 2. HK is our vertex, and all it is its opposite representation as far as with parentheses, because everything that is in parentheses we interpret the opposite. And K, it's what you see it. So if it was a +5, it is a shift 5 units up. So the last one is the factored form. And which form should you be good at? All 3 of them. Because if you're good at all 3 of them, you're going to go through these problems very quickly despite however they ask them to you. Okay, so the midpoint is you're going to find the midpoint of these x-intercepts as far as just adding them up together, whatever they are, and dividing by 2. This is the midpoint. So if I wanted to find the vertex from factored form, I'm just going to find the average of their x-intercepts. All right, so let's go ahead and go through some problems. Out of 1 through 3, which one do you all want to do that you think looks more difficult? 3. Okay, looking at 3. What form would I use? Standard, factored, or vertex? Come on, guys. Vertex form. So this is vertex form. So the vertex is going to be, what's the x value? 7, and then -3. So 7, -3. Okay. Second, let's look at x-intercepts when y is 0, y-intercepts when x is 0. Guys, if x is 0, can someone tell me what would the y value be? 49 minus 3, 46. So I have 0, 46. Or you could put y is equal to 46. If I'm looking for the x-intercepts, I'm going to set this equal to 0, and I'm going to solve for x. Here we go. What do I do first? Add 3. What do I do most important second that a lot of people forget? Square root with a plus or minus. Okay? So square root with a plus or minus will give me x minus 7 is equal to a positive or negative square root of 3. So when I'm adding the 7, I have a positive root 3 plus 7, and I have a negative root 3 plus 7. both of these are x-intercepts. Okay, and you can write them as plus or minus root 3. Whoops, this is a 7. Plus 7, and then 0. Questions? Okay, so let me ask you this. Transformations helps a lot with vertex form. Is it looking upward or downward? Upward. So if it's looking upward and it was shifted 7 to the right and 3 down, it looks something like this. Does it have a min or does it have a max? It has a minimum. Now listen, what is the minimum? Negative 3. Okay, don't put 7. Don't put 7, negative 3. What is the max or min? Just negative 3. What if I said, where is the minimum? What would you say? 7. Or x equals 7. Okay? All right. So from these three, which one do y'all want to do? 6. What form is this? This is factored form. So immediately what I want you to think of is the graph at x-intercepts what? 3 and negative 5. Is it looking up or down? Up. So some of us are in pre-cal now and may learn this year. Some of us already took pre-cal and already learned it last year. To see if it looks up, we're just looking at the coefficients of all of those leading exponents and seeing that it's going to be a positive x squared. So it will look up. So looking at this, it will look up like this. And if I asked you, guys, can you tell me what this x value is right there? What would you do to find that quickly? Add the two up together and divide by 2. So you have negative 5 plus 3 divided by 2. Anyone is what? Negative 1. So negative 1 is going to be the vertex. And what would the y value be? Is there a question? Oh, okay, I thought there was a question. So we're going to plug this back into the original, and what do you get as a y value? So you get negative 4 times 4, so negative 16. So negative 1, negative 16. And is it a max or a min? Min. What's the answer? Y equals negative 16. So x-intercepts. How many of those do y'all see? 2. And these are easy because it's in factored form. So you'll say x is equal to 3 and negative 5. And then y-intercepts is when x is equal to 0. Anybody, what would you get? Negative 15. Questions? Okay, so factored, standard, and vertex. Guys, can you tell me real quick, what would the x value, or what would the vertex be here? Remember? Negative b over 2a. So this is 4, negative 1. So 2 what? 2, 1. So negative 4 is negative 4 plus 8, 4. Yep, nice. Nice speed too. 2, 1 on that one. All right, let's keep going. Let's go to number 7. For the graph in factored form, which equation below shows the equivalent to this function, but in vertex form? This probably takes a good 30 seconds. Let's see how you do. And then we'll talk about it real quick. As you're doing that, I'm going to be writing the solution up here. So guys, let's use our answers to help us out. Which one do we know that it's not for sure? Which ones can we eliminate? B and D. So it's, and we can also eliminate C. Well, it's not really in vertex form because it's not squared. So we could eliminate C as well. So the only one that's in vertex form is this one right here. And we saw that there's zeros when we add and divide by 2, the midpoint would in fact be 3, which is what you see right here. Okay, let's do number 8. Number 8, you should probably be able to do in about 5 to 10 seconds. And what do y'all see as being the answer? Anyone? C. Yep. Because of vertex form, the opposite of -1. Wait, hold up just a bit. It would not be C. It would be what?
Wait. It said which one does it not have?
Oh, I'm sorry. Which one does not? Nice catch. Does not have -1,4. So we know that this one does. This one has a positive, so it's going to be C. This one has positive 1,4. Question. All right, so let's keep going. Let's go to solving equations using quadratic formula. We're going to identify when and where do we use quadratic formula. So, from these 4, at a quick glance, which one do you think we will need and it will require us to use quadratic formula? Number 1? And someone said 4? So let's check those real quick. Now, number 1, this is back to that number sense way that I was showing you. The first 2 will multiply to get that. I'm thinking 3x and x. Then these other 2 will multiply to give me a -10. I'm thinking 1 and 10 and 2 and 5. So 2 and 5 are the ones on the middle that I would go for first. Now watch. If I put 5 here and 2 here, I have 5 and 6, which will either give me an 11 or 1. That's not the 7 that I need. Okay? So if I switch them up and I put a 2 here and a 5 here, I get 2 and 15, which will either give me a 17 or a 13. Far, far away. Okay? Now let's go back and we're going to go to the extremes. Because guys, when you need the extremes, which will be rare, but sometimes you'll use them, you can avoid from using the quadratic formula. So let's do 1 and 10. If I try 10 and 1 here, I have 10 and 3, which will give me a 13 or a 7. So I avoided the quadratic formula from a number sense that works with everything when factoring. If it doesn't, very rarely does it not, then you would use the quadratic formula. I'll show you what to do then. So this would be a positive 10, -1, so that real quickly you can just set these equal to 0, and you get x is equal to a -10/3, and x is equal to 1. Faster, more efficient, strengthens your number sense, and at the same time, you avoid simple, careless mistakes with negative distributions inside of a quadratic function. Okay? Let's do 4 just real quick for the practice. We have 4x squared, and the things that I was showing you from before, I would probably go for the ones in the middle, not the extremes. No, I'm doing 4. I'm doing it higher so that you could see it. I'm still doing number 4, guys. I'm just doing it higher so that you can see it in the back. So 2x, 2x. Now I need these other 2 to multiply to a form of 3. So that's just one choice, 1 and 3. And now I have a 2 and a 6, which either give me an 8 or a 4. But I need a 7. You with me? So that didn't work, and I know that the 3 and 1s, they are where I would need them. I mean, there's no other choice. So now I got to look at the extremes. So it's got to be 1 and 4 possibly. Go with me? So if I put 4 and 1x, you see a 3, you see a 4, which will add to get 7 or subtract to get 1. Now you just have to get your signs all lined up. So to be a negative and a negative, because two negatives multiplied together give you a positive 3, and two negatives added together give you that negative 7 that you needed. So you have x is equal to 1, and x is equal to 3/4. Done. No quadratic formula necessary. The things that I just did, if and when they don't work out, then we can go to quadratic formula. Okay? Let's try number 3. We have x and x. We have 5 and 1. You with me? This will either give us a 4 or a 6. That's it. So here we've identified from trial and error, from building up number sense, I need to do quadratic formula on this one. Okay? So let's go ahead and do that real quick. Most common error is people don't use parentheses or don't understand parentheses. So negative b plus or minus is the square root of b squared minus 4ac all over 2a. I see a 144 adding a 20. I see a negative 12 all over 2. We practiced this in the summer with simplifying radicals. Let's see if you remembered. What numbers did I tell you that you could start dividing by because you're trying to get them all big chunks as soon as you can? What would be the first number that I would tell you to divide by? 4. Perfect. What would be the second number that I'll tell you to divide by? 9, because it's 3 squared. And then the third one? 16. Those are the numbers that you're going to try. So let's try 4. We divide a 4 out, and we know that 16 and 4 is going to give us the 41. So negative 12 plus or minus the square root of 4 times 41 all over 2. What will this come out as? A 2. So we have negative 12 plus or minus 2 root 41. Guys, is 41 prime? Yeah, 41's prime. You can't divide anything other than 41 and 1. So now, anyone, what would this reduce to as your final answer? Yep. Plus or minus root 41. Guys, if you didn't get that, you need to remember when you have one term, a lot of people struggle with this, even in calculus, it's the same as that. It's split up when there's addition and subtraction, not split up if it's multiplication. Are we good?
Where's the 2 go from front of the radical?
It's from, this 4 came out as a 2.
Why is it? So that, they both.
Cancel to a form of 1. Okay? Alright, let's keep going. So simplifying fractions. Let's go to something called the discriminant test. Another huge tool that I think people should have in their arsenal and not overlook. The discriminant test is a piece of the quadratic formula. And it's this piece right here. Alright, discriminant test. B squared minus 4ac. B squared minus 4ac, if it's positive, I have a certain amount of answers. If it's equal to 0, I have a certain amount of answers. And if it's less than 0, otherwise negative, I have a certain amount of answers, okay? So when I'm looking at this, I want to know how many real solutions do the following equations have. I can go straight to the discriminant test. I don't have to factor. I don't have to do the quadratic formula. I can use what I know of this kind of theorem-ish, and I can go straight to the answer. Okay? So B is 5, A is 3, and C is negative 10. I see 25 plus 120. I don't really care what the number is. I just know that it's going to be a positive. Do y'all agree? So because it's going to be a positive, how many real solutions do you think I'll have? 2. 2 real solutions. and they would look something like on the graph, you could see two separate x-intercepts. Okay? The other one, it's equal to 0. Actually, let's do that one last. What if it's negative? What if it's what if it's negative? What would it be here as far as how many answers and what would they look like? So non-real solutions, right? But there's still two answers. Okay? So we're going to put two non-real solutions. And the way that looks like on a graph is it's still going to have this parabola curve to it, but it never touches the x-axis. Okay, some of you haven't taken pre-calc all the way there yet. There's still two answers there, but they're imaginary. They have eyes. You know what I'm saying? Square roots of -1. And then here, you have two real answers, or one double root. You with me? There's still two answers because it's x squared. If it was x cubed, there'd be 3 answers. If it was x to the 5th, there'd be 5 answers. But the thing is that these are, it looks a little bit weird. These are a double root. And what does that look like graphically? Anyone? It barely touches it. It bounces right off the x-axis. And think of it this way. If I had x squared and I shifted it 2 to the right, it would look like this. You with me? And this is the same as this, which is the same as x equals 2 and 2. That's a double root. It's the same answer, duplicated, but it accounts for still 2 answers. You with me? One double root is two answers. Okay? And yes, that would look like on the graph, like Matthew said, it's just going to bounce off and actually touch it. Questions on the discriminant test? Okay, so this one would have 2 real solutions. All right, let's come over here. So there's a pattern to this. A lot of people overlook this. You'll see it on ACT for sure. And yes, they do put it on SAT and ACT or PSAT from time to time. It comes in a pattern of 4. Because here we go. I to the 4th times I is I to the what? 5th. I to the 4th times I is I to the 5th, because you added their powers, right? Now, you tell me, what is I to the 4th equal? 1. And I is this. So what happens on 5 is it repeats back to what it was at 1. At 6, it would be here. At 7, at 8. 9, 10, 11, 12. Patterns of 4. Are you with me? So you tell me, what would I to the 97th power be? It would be this right here. And the way you could do it, take 97. It happens every 4. Divided by 4. 9 divided by 4 is 2. 4 for 16. My remainder is 1. You with me? So if your remainder is 1, it's going to be this one. How many remainders do I have here? 2. Careful. 0. So 2, 3, and if you had a remainder of 4, you should have divided by 4 one more time. But if you don't have a remainder, it will be 1. Okay? Alright, so let's do some problems on that. Let's go to our first one on this homework. Is I to the 5th. We just talked about it. What's I to the 5th? Square root of -1. Because it had a remainder of 1. What remainder does I to the 17th have? 1. So it's square root of -1. Careful. Do that off to the side if you need to. What remainder does that one have? 0. So what does that equal? 1. Nice speed. All right, 4 through 6. Which one do you want to do? 6? Okay, let's do 6. I see the two i's. Multiplication does not have order, so I could do this if I want. Multiplication does not have order, but also we learned in Algebra 2 that those square roots can be brought together under the same thing. So this is going to be a positive 36 square rooted with an I squared. And there are two that you're supposed to memorize. I like to memorize this one right here because you use it so many different places. So anyone, what does this look like it's going to be? Negative 6. Now let me ask you this question. This square root of 36, from what we've talked about, should I put plus or minus 6, yes or no? Or is it just 6? It's just 6. The only time that this would be a plus or minus is if and only if it's set equal to a variable squared, 4th, 6th, 8th. There has to be a variable there. Then it would be plus and minus. Okay. So now, let's move on. We're going to set some up. Let's do 10, 11, and 12. Our goal is to get rid of i's as much as possible, just like you would get rid of square roots in the denominator. Here we go. For this, we get what? 108 outside, inside. So 72 and 36. You with me? 72, 36, you're adding, but you're having a negative, would be 108i. And then last but not least, a positive 24i squared. And there it is again. You with me? So it's the same as subtracting 24, which would be 84 minus 108i. Understand that the default form is a plus or minus bi, almost like y equals mx plus b. Questions? Okay, so let's move on to number 11. Our goal is to simplify. Our goal, when we simplify, and you saw this way back in Algebra 2, you'd multiply by a form of 1 so that you could make this no longer a square root. That's kind of what you want to do here. We're going to multiply, we talked about this in the summer, by a conjugate. A form of 1, something over itself, but is a conjugate that will cancel out these i's in the denominator. Does anyone know what that is? Yes, 11 plus 7i. 3 words that I see now, right here. What are the 3 words? Difference of squares. Difference of squares. So it's going to be, these two multiplied would give me a negative. The first term is 11 squared. The last term is 7i squared. So the denominator becomes 121. This is 49i squared. But we're going to subtract the negative 1. So it's the same as adding 49. Go with me? So what would the denominator become? 170. The top is still 88 plus 56i. And if you're needing to get it into that form, you could, if you want, just break it up and simplify. 88 over 170 plus 56i over 170, and then just simplify from there, reduce. Okay? We have 2 minutes. All right, so this will be our last problem right here. It is another form of a conjugate, but there's a little bit more that we have to do with the final answer. So anyone, what's the form of 1 that I'm going to multiply by? Yep, 2 minus 5i over 2 minus 5i. The square, difference of squares on the bottom, you get a 4 minus 25i squared, which is 29. And then the top, it's not a difference of squares, it's this. It's like 2 minus 5i squared, which is 4 minus 10 times 2 is minus 20, and then plus 25i squared. You're just folding, distributing. So it'd be 4 minus 25, which is a negative, what, 21? Negative 21 minus 20i all over 29. And yes, you could simplify it out to this if you wanted to. Guys, listen, the polynomial part of the homework includes a lot of the factoring, includes a lot of the things that we just kind of went over. Please make sure that you try to get it done by next class.